All right, this video is going to focus on the product rule from 2.4. I'll have a second video, part 2, that focuses just on the quotient rule. These are the extra examples from our notes that we did in class. So I'm going to be starting off with number 2. And we're looking, remember, at our formula for how to do the derivative of a product of two functions. So remember that we have derivative with respect to x of f of x times g of x is always the derivative of the first, write it in words is easier, times the second function plus the first function times the derivative of the second. So you need 4 things to be able to do this formula. You need to know your first and your second function. What are they? So you have to define them. And then you need the derivative of both. Now for number 2 here, they already called this f of x. So you can always rename your functions whatever you need them to be so that they don't match this, because you don't want that to get confusing. So I'm going to let the first function be h of x and the second function be g of x. So then for my first, I'm going to write that h of x is 3x squared plus 1. H prime of x, remember you take the derivative of that. So you bring the 2 to the front and multiply it by the 3, so that'd be 6x, and we reduce the power, so that would just be 1. And then we have this plus 1. Remember, if you take a derivative of constant, it is 0. For my second function, g of x, the original function is 6 minus 3x. The derivative of that, 6 will give us nothing because it's a constant. This has a 1 on it, so you pull the 1 to the front, multiply, that makes -3, and then the x would reduce down to a power of 0, which makes it just the number 1. So it's just -3. So if we want to take the derivative of our entire function f, we go by our rule. It's derivative of the first, which would be 6x, times the actual second function. So notice if we've written it like this, you see that that's kind of in a diagonal together, plus the first function, so that's the 3x squared plus 1, times the derivative of the second one, which is -3. We work this out, so this is 36x minus 18x squared, plus we need to multiply everything here by -3, so that'd be -9x squared and -3. Combining like terms, we get that that's going to come out to -27x squared plus 36x minus 3. So that's how we take the derivative of a quotient, or excuse me, a product. Hard to think and talk. So the other ones that we did number 3 in class, so we're moving on to number 4. I'm going to try to color code a little bit this time so you can see where everything's labeled a little bit better. So this is just y, so I'm going to call the first function f of x, and I'm going to call my second function g of x. So for my first function, we have that go back to red. So first function is in red. So first function, we have f of x is x to the 4th minus 2x. F prime of x would be, pull the 4 to the front, 4 times 1 is 4, reduced by a power, so that's x to the 3rd. This is a 1, so pull the 1 to the front, that's still -2 when you multiply, reduce the power, and the x would become x to the 0. So that's going to be my derivative for that one. For the second one, it's better, I would go ahead and write it as 6 over x squared, but for derivative purposes, you want to write that as 6x to the -2. So g prime, we pull the -2 to the front, so that makes 6 times -2 is -12, and we'd reduce the power, so that's actually x to the -3. So that one is -12 over x to the 3rd. We always use the fractional parts when we plug it back in. So for our derivative, y prime, we have, let's see our colors, the derivative of the first, which is 4x cubed minus 2, times the original second function, which would be 6 over x squared, plus, then we have the first function, so that's x to the 4th minus 2x, times the derivative of the second one, which would be the -12 over x to the 3rd. Okay? So now we want to distribute and work this out. So we're going to, okay, so for this, if you think about it, you can write it out long ways if you need to. Sometimes that's more helpful for people If you distribute this, this would be a 6 over x squared times the first term and a 6 over x squared times the second term. For this one, we have the x to the fourth minus 2. Well, let's write it in two pieces. Let's do the x to the fourth times the negative 12 over x cubed, and then the minus 2x times the negative 12 over x cubed. I'm running out of room right there. Okay, so let's just see if we can walk through this. So y prime would be, here all of the x's are going to cancel except for 1 on top, so that's going to be 24x. For the middle one, you get negative 12 over x squared, since no x's cancel. For this one, 3 of the x's are going to cancel out, so that's going to leave you with a negative 12x. And for the last one, you have x to the third on the bottom and x on top, so that's going to cancel one of the x's, and it's a negative times a negative, so it's a positive 24 over x squared. If we combine like terms, 24x minus 12x would be 12x, and negative 12 plus 24 would be positive 12 over x squared. Since they both have the same denominator, we can add those together. Now that is one way to write your answer. Depending on what WebAssign wants, they may want you to make this one big fraction. So just depending on if they like this or not, you might want to try making one fraction. Or if it says in the directions, write your answer as one fraction. So if we think of that being 12x over 1 plus 12 over x squared, we would want to multiply this first fraction by x squared on top and bottom. So that means it's 12x cubed plus 12 over x to the second. So that would be it broken up into one big, or excuse me, put together as one big fraction. So that's another way of writing the same answer. So I'm accepting this on the test. If you have it like this, I'm good. Okay, let's talk about number 5. Number 5 is a little bit more complicated in terms of work we have to show because we have a trinomial. And actually, I know I'm going to take a lot of room to write these, so I'm going to see if I can go ahead and shift down 6 a little bit further on the list so that we have room. There we go. So let's shift this down. Okay, so we're dealing with f of t, so I'm going to call my two functions g of t and h of t. Doesn't matter which one we write first. Just because g is already one of the functions we're used to seeing, I'll write the h one first, where the f usually would be. So h of t and g of t. So we're going to list those out. So for first, I know that h of t is t to the fourth minus 5t, which means h prime of t would be 4t cubed minus 5. G of t is 3t cubed plus 8t minus 7. G prime of t would be 9t squared plus 8. So that's what we have for that. Okay. And now we're going to be working on setting up our formula. So f prime of t equals derivative of, remember, the first, so that's going to be the 4t cubed minus 5 times the second one, which is the 3t cubed plus 8t minus 7 plus the first function, which is t to the fourth minus 5t times the derivative of the second, which was 9t squared plus 8. Okay, so now we have to work all of this out. So I'm going to come down here a little bit and give myself some room. So we're going to be doing 4t cubed times everything. So if you really just wanted to write this out, you could. If you can do it in your head, that's fine too. So I'm just writing out all the steps of just this first blue and red multiplied together. Then we have to do all of the red and blue in the second pair multiplied together. So that's going to be a t to the fourth times a 9t squared plus a t to the fourth times an 8 minus a 5t times a 9t squared minus a 5t times an 8. Okay, so let's work this out piece by piece. So for the first one, we get 12t to the 6, because you add the exponents, plus 32t to the 4th, minus 28t cubed. Then we would have negative 15t cubed minus 40t plus 35. So that's getting us to right here. On the next line down, we would have plus 9t to the 6th plus 8t to the 4th minus 45t cubed and then minus 40t. So combining like terms, we're going to have the following. 12 plus 9 is going to be 21t to the 6th. And then we have 32 and 8. Those are our only t to the 4ths. So 32 plus 8 is plus 40t to the 4th. Then we have negative 28 and negative 15 and negative 45. So I'm going to get my calculator. So they're all negative, so I'm just going to add. So 28 plus 15 plus 45. So it's going to be a negative 88 t to the 3rd. We don't have any t squared. We do have some t's, though. That's a negative 80t. And then a positive 35. Now, there's nothing more difficult, I would say, about this one, except just keeping all of your terms together and being careful with them. So that's the most challenging part about the ones that have larger polynomials. Okay, so let's look at this next one, number 6. Okay, for number 6, it doesn't look like a product typically, but this is being squared, so you can actually think about writing this twice. So it's 3x squared minus 9x plus 4 times 3x squared minus 9x plus 4. Now the nice thing is, in the next section we cover together in class, we're going to teach you a quicker way to do this one because it's being squared. There's actually something else we could do that will save us some time, but for right now this is what we have. So we're going to let h of x be the first function and g of x be the second one, which they're identical. So let's do h of x. So for h of x, that's our first function. It is 3x squared minus 9x plus 4. The derivative of it would then be 6x minus 9. For the second function, it's going to be exactly the same because it is the same exact function. So the first and the derivative match for the second and the first function. So when we put this together, you're going to see something a little interesting. So f prime of x is going to be the derivative of the first, which is 6x minus 9, times the original. So that's 3x squared minus 9x plus 4, plus, then you're going to have the first, which is 3x squared minus 9x plus 4, and times the derivative of the second. Now, because these are exactly identical, you really could just FOIL out one of these completely or distribute it and then times the answer by 2 because you're going to get the same thing over here. But we're just going to work it out. So 6x times 3x squared is 18x cubed. 6x times negative 9x is negative 54x squared. 6x times 4 is 24x. Negative 9 times 3x is negative 27x squared. Negative 9 times negative 9x is positive 81x. And negative 9 times 4 is negative 36. Now, because this is a plus, this is going to give us the same thing. You could just line these up and write that it's the same answer twice for each one of them. And then we can add that together and then see if there's any like terms that we can combine. So that would be 36x cubed minus 108x squared plus 48x minus 54x squared plus 162x minus 72. So that's just adding all those repeats together. And then we do have some like terms we can combine. So f prime of x would actually be 36x cubed. We have a negative 108 and a negative 54. If you add those together, that's negative 162x squared. 48 plus 162, it should be 210x and then minus 72. So there is the derivative of that one. Okay, so then what's left in this section was another tangent equation problem and then one where we had to do the f prime of 2. So let's do number 8 next. It says find the equation of the tangent line to the graph y equals x squared minus 1 times x cubed minus 3x at a specific value of x equals 1. Remember, equation of the tangent line means that we're going to need the derivative at the x value to equal our slope. Once we have the slope, we can usually find the other piece. Now, I want you to notice that the one we did in class was number 7, and we had a point already. They didn't give us a point, they just gave us x equals 1. But if you need the point, you just plug 1 into the original function, and we will need it at the end. So 1 squared minus 1 times 1 cubed minus 3 times 1. This would be 0, and this is negative 2, so that's going to be 0. So this is actually the ordered pair 1, 0. We will need that when we go to get our equation at the end. So the first thing is to find the slope of the equation we need the derivative. So I'm going to label this first one as f of x, and the second one as g of x, since this is a product. So f of x is x squared minus 1. That means f prime of x would be just 2x. G of x is x cubed minus 3x. So g prime of x is 3x squared minus 3. Write those down. Derivative of the first is 2x times the second function plus the first function times the derivative of the second. Distribute everything out. We get 2x to the fourth minus 6x squared. This one we'll have to distribute by FOIL. That will be 3x to the fourth minus 3x squared minus 3x squared plus 3. So I'm getting that I have 5x to the fourth minus, let's see, this is negative 6, take away 3, that's going to be minus 12x squared, and then plus 3. Now that's our derivative. To find the actual slope of the tan, you have to evaluate the derivative at the value of x that they gave you. So that's 5 times 1 to the fourth minus 12 times 1 to the second plus 3. That's going to be 5 minus 12 plus 3, which is a slope value of negative 4. Yes. Okay, so that's my slope. So now I have my slope and I have my point. Remember, my point was 1, 0. So I plug that into point slope to get my equation of my tangent. So this is just y. This would be negative 4x plus 4. So there's the equation of my tangent line. Okay, and the last one in the product section before we move on to the quotients is one of these where they give you a bunch of numbers and they ask you to symbolically find f prime of 2. So when we look at this, we need to first of all focus in on what the actual function is. This is the function that they're asking us to find the derivative and evaluate it at 2 on. Usually everything here at the beginning is just information we'll use. So we're just asking, how do you take the derivative of that function? Well, since it's not a product, we won't need a product rule. What we just have to realize is that it's going to be 2 times the derivative of g of x minus the derivative of h of x. So it's a very straightforward. The 2 out front is, remember, just a coefficient, so it just gets multiplied by whatever the derivative is. So all we need actually to do this one is the derivative of g prime and the derivative of h prime. So f prime of 2 is 2 times negative 2, because that's this evaluation, minus 4. So that's negative 4 minus 4, which is negative 8. So if you don't have a product rule here, there's no reason to use all of the pieces of the information. Whereas we did 10 in class and we ended up having to do a product of g and h, and that made us use all of the pieces that were given to us. So just because it's there doesn't mean it's always used depending on what the derivative is. And that's the end of the product portion.